Hi Year 10, this is a small video just to remind ourselves how to use Excel in order to determine a regression line. So I've got some model data in here where we're looking at the relationship between our independent variable of homework to a dependent variable of exam score. So predictably we could expect that the more homework you do per week, the better you score. So let's look and see what happens here. So I'll select all of this. Insert a scatter plot. I won't worry about labeling the axes or giving a title at the moment, but please make sure that you do it. But over here, under chart elements, I'll add a trend line. Now the default one of these is linear, and as you can see, we've got a straight line which is trying to model a curve. So whilst it will give us some a regression equation, and we can check that. Sorry, I'll go back through that again. So under here by trend line, we can click on here, go to more options, and you can see linear is one of the trend line options being listed, and we can actually display the equation on that, or of that line, that straight line there. But as I mentioned before, there are other options for this. So if I delete that and go back and add my trend line, but this time perhaps choose something else that might fit better. So we can see the exponential there perhaps works a bit better in terms of fitting the data than our linear does, and therefore might be a better model. Logarithmic just doesn't work for us. And then we've got things like powers and polynomials. I'll use powers first. I'll try to use powers first. So selecting power, it doesn't seem to want to play. So maybe if we go to something like a polynomial, and here you're asked to stipulate the order. So polynomial is things like an x squared graph or an x cubed graph. So if the order is 2, we're looking at an x squared graph, and you can see that the line that they've fitted here fits quite neatly. And once again, we can go down and display that equation on the screen, and it tells us, or that equation can then be used to predict what might happen if, for instance, we've got a person who does 1.5 hours of study. What might actually be the outcome of that? Sorry, we've got a 1.5 try 1.7 hours of study. What might we expect for that person to get? So we can actually put in here that that will be 10 times our value here squared. Now this little, so I'll use that from here, the 10 times x squared, where x is our value here. Now I'm going to subtract 2 by 10 to the negative 13. That's a particularly small number, but 2 by 10 to the negative 13 lots of x. It's close enough to 0, so I'm not even going to put it in. And then I'll add the 10 there. And so we can use that model that we've got to actually say my 1.7 hours of study, I can predict I'll get about 39% for that particular student. So just highlighting the important parts here, not all data is modelled as a linear equation, and sometimes there's a better fit. We've got to determine that better fit, and ideally that's done with a quantitative value. So some way we can say, look, here's the reason why I've chosen one particular graph type over another, or one particular trend line over another, and then we can use that equation that we've got to generate values to test whether our model actually works or what we might expect from our model. Okay, thanks very much. I hope this has helped.